thought it might be interesting to see some of the other Turborocket engine prototypes in the great pantheon of Turborocket engine development here at Turborocket. So here on this shelf we can see about 5 or 6 previous prototypes of Turborocket engines. In a previous video I showed the Turborocket Mark 6 unit on the stand. That's our latest model. But here are the predecessor engines, the Mark 1 through 5. So starting here on the far left, you can see the earliest prototype. This is the Turborocket Mark 1. This was the very first Turborocket engine we produced. It's a small, relatively small engine. It's about 1.25 inches in diameter. It has 2 nozzles. You can kind of see those there. This engine was actually designed and built for integration with a small turbojet engine to produce the combined cycle engine known as the RTR Turborocket engine, which if you Google the patent for rotary turborocket engine, you can find that patent. So this engine was tested extensively, both in conjunction with the turbojet and also by itself, where we tested this small turbojet engine for actually probably on the order of over an hour of continuous hot fire test time with this little engine. Some of the videos that you see also on the Turborocket channel are made with this engine. Next in line we have the Turborocket Mark II engine. This was the first prototype engine to utilize 3D metal printing to fabricate the rotor head on it. We used lessons learned from the Mark I to develop this engine. It has 3 nozzles that have a fixed beta angle, fixed nozzle angle. Issues with the Turborocket design on this particular model proved to not be, we couldn't overcome those, so we moved on to the Mark III engine. Here we can see the Turborocket Mark III Turborocket engine. Now this unit features a variable beta angle and was the first prototype that we had which had this capability. The nozzle angles are allowed to can rotate or can pivot even as the rotor head is pivoting. So you can kind of see as we traverse the actuator mechanism that the nozzles can pivot. This allows the rotor to change velocity. We can also set it to 0 and stop the rotor and even reverse direction. So that's a way that the Turborocket engine can be throttled using these variable beta angle configurations. So this model, the Mark III, was printed in plastic and then tested with compressed air. Using lessons learned from the Mark III, we went on to the Mark IV design, which was also fabricated with plastic. This one has a 3-hole design and has the variable beta angle actuation configuration. We printed it in 3D plastic to work out a lot of the design details before moving on to the metal version of the Turborocket Mark IV configuration. So this unit, as you can see, was made with 3D metal printing in conjunction with conventional subtractive manufacturing. And we hot fire tested this one relatively recently. As you can see, sometimes testing is a harsh reality, and we ended up melting components on this engine. But we learned a lot, and it allowed us to move on to the Mark V Turborocket engine design as shown here. This design is a two nozzle design, and it has a fixed beta angle, unlike the predecessor Mark IV engine. This was just to design and develop a sort of a baseline minimum viable product kind of Turborocket engine that could be used for evaluating Turborocket engine performance and comparing it to our computational methodology and modeling attributes. So there you have the summary of the first 5 Turborocket prototypes here at Turborocket. Using these engines, we'll continue to develop the technology here, and hope to have some working prototypes here that will demonstrate the efficacy of the Turborocket engine concept. Thank you.